Hi, Chantel. I think we'll start in the next minute or so. Okay, I think we can kick off. I know our guests are here and Alela is here. Alela, are we good to kick off?
Yes, we are.
Okay. Perfect. So welcome, everyone. My name is Max Musau. I'll be your moderator for today. And I'd like to welcome you to the Devs on Air session with DeCodEd. The webinar series is a series of conversations with different tech teams and CTOs from across Kenya that are leveraging Google and other open source solutions to build solutions for Kenya and beyond. And we've kind of partnered with Google to be able to do this because we feel it's important during this period of the pandemic to be able to keep engaging the developer community in Kenya. As we all know, a lot of the in-person meetings or events have been cancelled for we think for the next couple of months as the situation dies down. So this is our way of kind of engaging the community and bridging the information gap between devs and industry and people just beginning to start up. So karibuni everyone. We're happy to have you. Maybe just a brief background on DeCodEd. DeCodEd stands for Democracy, Code, and Education, and essentially it's a community space for developers to meet, learn, and grow their skills, as well as tap into industry knowledge and industry opportunities to tackle the jobs of the future, while at the same time building the African developer economy. So this is what DeCodEd is about, focus mainly on developer communities. A bit of ground rules. We'd like everyone kind of to turn off their camera just to save on data, and everyone's mic should be off. And if we have any questions, we have you can post them on the chat, or you can use the link in the chat to be able to ask the questions. I think that's all the ground rules. Alela, have I missed anything?
Nope, we did.
Okay, good. So the next hour is kind of like a chat with some industry experts, and we'll kind of do it in the format where we'll take the first 45 or 35 minutes just to have a chat, to know who our speakers are, and to engage in the topic of this week, which is developer operations, specifically talking about CI/CD, and we'll take the first 35 minutes to have a chat with them, and we'll spare the last 15 minutes for any questions that anyone might have. Cool. So our guests today are William Ondenge, who's a technical product manager at Choma Connect, and Amos Jenga, who's a DevOps manager at Safaricom, and myself, your moderator. My name is Max Musau from DeCodEd. I'm the learning programs lead at DeCodEd. So karibuni everyone. I wonder if we can get William to start with a brief introduction and background to himself.
Thank you, Max. Is everyone able to hear me?
Yes, William, we are.
Yes, my name is William Ondenge. Thank you all for joining us this afternoon to converse about some of these technologies that we can use to enable our products that we use. Like Max has indicated, my name is William Ondenge. I'm based here in Nairobi. I've been involved in developer operations for the last 5 years. And my career spans about 13 years. 7 of those years I spent in a research organization in Nyanza doing community development, where I learned a little bit of user design and user interactions and things like those. And then in the last 5 years, I've been involved in a lot of developer operations, mainly with Golang, because I'm highly specialized in Golang. And that is the language that I use to build some of these cloud native architectures. And most of the products that I build are revolved around financial technology. So these are integrations with mobile wallets, and also processing companies like Visa and MasterCard. Some of them are in Kenya, some of them are within the region, and some of them work globally. So basically, that is my experience in a snapshot. But as I would like to say, I also have like some experience with developer operations tooling. So these are things like CICD that you're going to talk about, package management, configuration management, and also a little bit of infrastructure as code. So in short, that is the introduction. So Max, you will guide us from here.
Thanks, William. Over to you, Amos.
Okay, thank you very much. I hope I'm audible.
Yes, you're very clear.
Okay. This is my first community event, and I thought it's good to come and maybe share my experiences in DevOps or developer operations, having started as a solutions architect about 13 years ago in Safaricom, and maybe moving to system administrator role and a bit of business engagement, where I was a liaison between the technology team and our business teams. So the last 2.5 years is the time I've actually been working on DevOps. And for me, it's been more of a cultural champion on adoption of the practices and the tools that you can use, and mainly influencing how we can accelerate that within Safaricom. That's about it. I have a bit of experience on both cloud native technologies, generally in the last 3 or 4 years. Over to you, Max.
Thanks, Amos. Karibuni, William and Amos. It's really a pleasure to have you guys with us. I think between the two of you, you guys have an amazing history and a lot of expertise to share with everyone. So, Karibuni, I guess we can dive right into it. So, I'm sure some of the devs who are out there who are just beginning are kind of trying to figure out, okay, so what's the whole idea behind developer operations? What's it really about? And as I build my app, when or why should I start thinking about developer operations? So maybe we can start with you, William. If you were to give like a brief summary of developer operations from end to end for someone to try and understand what would you point out?
Thank you, Max. I'd start with the core components of any business organization. First of all, before you start developing your products, first of all, before you start engaging with your customers, you must be within a certain type of organization. This can be a startup, this can be an SME, this can be an enterprise organization. So what happens is, within those types of organizations, you have like people who are shareholders. And the number one goal for that business is to maximize the shareholders' value. So any amount of capital that they put into the business, they must find value into it. So value is determined with things like profits. So how do you get your profits from these products that you are trying to build? So that is the number one goal of a company. So how do you help your help your shareholders to maximize some of these things? When you're talking about profits and you're a business person and you're involved in development of products, this can be either through mobile, through iOS or Android, web, or other channels. So what you want is that you are able to make profits. And how do you do that? You want to make sure that your costs, you save on costs, and then your time to market is also quick, and also you're very agile in terms of making changes to and from the market. And naturally, some of the tools that we've had in the past, let's say 15, 20 years ago, have more or less thrived in environments where we build and build and build and build and maybe ship twice or thrice in a year. So this concept of DevOps, we can pick it from the point where you want to help the organization reduce the costs in terms of the computing resources they have. And also you want to encourage them to deliver faster to market. And also you want to make them to be agile. So basically DevOps is this thing that now it's a culture where your organization now ventures into things like continuous communication, where you continuously communicate with your peers within the organization, your managers, and sort of things like those. And also you continuously collaborate. And then your products that you build, you make sure that they're integrated well. And also one key component is about automation across the whole organization setup. So basically DevOps is a process. It is not a tool. It is a culture, rather not a process or a tool that you can say, okay, we want to adopt DevOps as a tool, or we want to adopt DevOps as a process. So the first place where you have a conversation is it's a culture shift. How do you do all those sort of things that I've talked about? Your costs, your time to market, and how you're agile. So when you're talking about costs, you're talking about things like, I think Amos will talk about these because they have a lot of computing power at Safaricom. So when you're talking about costs, there are certain products, say certain applications where you deploy them on your virtual machines, and then you could have various applications that you deploy on different sets of virtual machines. And some of the spaces within the virtual machine sometimes run unattended to. They are just they are left idling. So this makes the organization runs into high computing costs, which is leading to things like high wastages. So how do you make sure that you can use, say, one or two virtual machines to the highest capacity, and then putting all your applications that you're developing on the same set of virtual machine or your infrastructure? So basically, DevOps, that is what I think about DevOps.
Thanks, William. So in this process of building an app or building a set of apps, how do you deliver it faster to the market while reducing costs? This is kind of the idea of developer operations kind of thing. Amos, do you have something to add? What's your take on or rather your view on developer operations from where you're sitting?
Maybe to add on what William has just shared, the main idea behind it is actually to look at the value that you're actually giving to the customers and the quality of the solution that you've developed, and at the same time to accelerate that delivery. So when you look at traditional organizations, you have the development being done by one team, and then the solution is figuratively thrown over the fence to the operations team to manage. And that brings a conflict whenever you want to change or adapt the solution to meet customer requirements or actually to get more value from the customers. So the DevOps bit of it is to ensure that you can accelerate that value while maintaining the quality and stability and reliability of the solution. So that, and then that means we have to break down that wall of confusion that that has actually traditionally been in these organizations that have a separate operations and development team to always focus into cross-functional teams and adoption of the culture, and then identify the appropriate tools that will allow you to accelerate that delivery.
That's interesting, because you've talked about how do we kind of split the roles between the developers and the ones who are doing the developer operations, and how do they work together to create this pipeline that delivers value for the end user. So that's very interesting to note. I think the next question is for both of you again, and we can start with William. Why do you find DevOps interesting from your perspective and from the perspective of someone kind of beginning this journey into DevOps? What are the things to look out for from your perspective?
Thank you, Max. I think in my perspective and experience, DevOps is particularly interesting in a range of things, particularly when you're talking about things like policy at an organization level for your applications, when you're talking about things like observability, when you're talking about things like reliability of your applications and security. So it is interesting in a way that, for instance, I will say that most of the times organizations have said, like, put people in silos, just the way Amos has indicated, that we have developers whose role is to just build applications, then push it to ops. And then at some point you have security people who come in with their security expertise and figure out how things is. So like he said, there's a wall of confusion, and to make sure that these things, people are working in small pizza teams that is efficient, such that things like operations and security, these are things that are involved, I call it the day one challenge. So these are things that you involve in your application on day one, such that you think about things like cloud security from day one, where how your security is going to run in the infrastructure, how you're going to manage your secrets, how you're going to manage your API keys, how you're going to protect your database credentials, things like those. And then we have like tools that you're able to use to help you to do that. The other aspect that I find it interesting is monitoring and observability. When your application is already running and it's live, you want to be in a position where you know where things are going wrong, where things are going good, and such that you're able to be in control of everything that is happening. So on day one, you make sure that things like logging and tracing, these are things that you factor into your application, such that when you're doing these monitoring and observability, these are things that you can just do them on a flash. The other bit that is interesting to me again is how do you do your networking of your applications. This is something that sometimes, maybe Amos will talk about it since he was a sysadmin, but sometimes networking of the applications in places where you're talking about microservices, you have a lot of services and you want to make sure that they're properly networked together. You don't leave that for other groups of people, but you absorb it since day one. So particularly interesting again is the fact that you have tools that you can use from your desktop and ensure that the whole journey you experience it on your laptop, such that when you deploy it to production, then things are going to work really well. I think Amos can talk about things like how to do cloud orchestration, because he has experience with high-level data centers, and I think how to automate that within the concept of data centers. Amos?
Yes, we can all agree that one of the biggest challenges we have, especially in the so-called traditional enterprises, is environments. So people are always fighting about we don't have a test environment, the test environment or the OAT, operational assessment environment, is not the same as production. And you make a change to the code, and then you realize it's not going to run onto it's actually not going to work as it was working when you're testing it. So DevOps gives us the ability for us to treat that infrastructure as code, so that you have the same exact setup, maybe using some things like containers. And when you look at even the virtualization, and you're looking at some virtual machines, you can declare those as code, and you have version 1 of the code. And if you need to make a change, you commit the same declaration into code. So I think DevOps is interesting because it treats everything as code, and moving to declarative, scripting. So you define what the end state is. You'll always have infrastructure that you're not fighting with as you go along. So for me, the other bit is in terms of configurations. It's very interesting because I remember there's a time I spent a whole 24 hours trying to find configuration for a website that we are running so as to enable HTTPS. And it was just one line, and we had done the change on the production environment and forgot to do the same for our test environment. And we are not figuring how that is working. So I think those concepts and the tools that are there, they've been, there's a lot of open source tools that you're able to utilize to do some of this work, even at scale. And you're able to build infrastructure very fast. You don't have to wait for several days for you to actually come up with something that could actually work for you whenever you want to deploy your application. So I think apart from the bit of the deployment and monitoring, I think infrastructure provisioning as code is also very important and very interesting.
Okay, thank you so much, Amos. Sorry, Max has had to drop the call for a while, just until he's back. Thank you. But in the meantime, you can just add more points from William. From your perspective, what are some of the tools that you'd advise someone to use when they want to venture into DevOps?
Interesting. So just to summarize what we've been talking about, that DevOps is interesting because you want to deal with three sort of things that you want to take care of: how to build your application, how to deploy your applications, and then how to manage them. So those are the key tenets of an efficient and effective DevOps process. So some of the tools that I can talk about, since I'm experienced with Docker, I'll start with cloud orchestration in terms of how do you want to deploy your application into production. First of all, there is like you're developing your application as a junior developer, as a senior developer or engineer. So you have your application on your laptop, and then you want to, first of all, you want to decouple that application from the machine. So what do? You get a tool like Docker, and Docker is able to, because Docker runs on the low-level kernel, and it's able to decouple your application from your machine. So it gives you sort of an environment that is production-like, and it's very portable and self-contained. So you can use Docker on the first instance when you're using your local machine to try some of these things. And probably after that, you start thinking, okay, I have my application on my laptop. I am able to decouple this application from my machine. I want to deploy it to production. How do I do that? And then you think about things like cluster management tools. Now we'll talk about things like Kubernetes and Mesos. So Kubernetes is able to also now decouple the infrastructure that now Amos was talking about. Now, the first instance, you decouple your application from your machine. Now this second instance, you want to decouple your infrastructure from these things that you're deploying, such that you don't mind wherever you're deploying your application, whether it's on Safaricom servers, whether it's on AWS, or whether it's on GCP, or it's on Azure or DigitalOcean. You don't care whether these infrastructure are. You're able just to deploy them, so that it abstracts that away from you. So that now you use Kubernetes. Now after that, now you start thinking, okay, what is now the next step? The missing pieces now that I have. Now you start thinking about, how do I run my microservices in production? Or maybe you have a monolith that you're working on. How do you run that in production? Then now you want to decouple everything that you've been running, that is from the application level, from the infrastructure level, such that now you run things from the service level. Now you have tools like Istio that is able to help you to do that. All these are open source tools that are available on GitHub. And then you can really talk about things like, sorry, I lost my train of thought. Things like those that I've talked about. So I think Amos will talk about things like cloud storage. How do they do that in terms of how they handle the transactional DBs, object DBs, how they do cloud networking and the services they use, the open source tools, maybe a little bit of security, the tools they use. And security also, there is, maybe just to chip in a little bit, because I've talked about Docker and Kubernetes, we have, in Docker, we have something called Docker secrets that you're able to, when you're deploying your application now, the way I explained from your machine, maybe you have an API key, a database credential that you don't want to package, and you want to make sure that it remains secret within the whole package that you've developed. So there's Docker secret that you can use. And then when you move to Kubernetes, there's also Kubernetes secrets that you can also use. And then on your infrastructure, the whole set of it now, you can maybe utilize something like Vault from HashiCorp. So you can also use Vault HashiCorp to store some of these keys. So Amos, back to you. The tools that you use for storage, maybe networking, and things like those, open source, not the ones you built in-house.
Okay, that's interesting, because I would actually want to add some of the most used tools for CI/CD is something like Jenkins, that will allow you to orchestrate that pipeline for connecting maybe the tools for build automation, test automation, and deployment automation. So on the test automation, you have Selenium, Appium, and PyTest, some of the items you can actually utilize to do that. And maybe in different areas, you have also security testing, and there are many that you can adopt around container security automation. There's also the developers build tools, some things like Gradle, Maven, unit test and static analysis, SonarQube, JUnit, and the rest, depending on the software stack that you have. And then most importantly, we talked about the collaboration bit of it. So you may need to have a ChatOps set up for your handling of maybe notifications, incidents, and also team collaboration. So you can use something like Slack, Microsoft Teams. Google also has the tools they have here that they're utilizing to collaborate, like Meet. I think these are available to all of us in how we work. When you go to the infrastructure bit of it, we have very interesting tools like Terraform, and we can also look at when you're developing and you're starting out, you can use tools like Vagrant to set up a similar environment like the one you have in your production. So the beauty is that these tools are always, I mean, there are new tools that are always coming up, and the ones that we are already using are not the only ones that anyone can actually adopt. You need to actually look at what works for you, and then you put in there. For monitoring and observability, there are commercial tools, and also the cloud providers give you their own tools. Like we have things like New Relic, SignalFX, Dynatrace, Datadog, Stackdriver. There are many tools that you can actually adopt and use on the production environment and integrate it directly to your tools. I think I won't talk a lot about the tool because there are many, but the whole idea is you understand why you're using it and what it's actually providing in terms of the DevOps lifecycle.
Okay, thank you. So in terms of initiating your code build, running tests, deploying your code to a staging and then a production environment, what's the idea behind CI/CD or continuous integration or continuous development, and how does it fit into the whole idea of DevOps as a whole? Maybe we can start with you, William.
Yes, thank you. CI/CD is a methodology that is used to make sure that you're continuously automating. Basically, they call it continuous everything. Everything is continuous, from your code, from your how you work as a team. And one of the primary purposes and how you can effectively do that is you structure that in a position, you structure it well with how your teams are set up, such that when you're doing CI/CD, the workflows are very efficient and you actually get the value out of it. So basically, CI/CD is about continuously doing everything that we've talked about. Now that is continuous testing, continuous automation, continuous orchestration, continuous networking, continuous storage, continuous visibility. How do you all do all those things together? And there are certain sort of workflows that you can always use. For instance, I use a pretty easy workflow that first, when I build on my laptop, I commit code on my laptop, either through the IDE that I'm using or through just the normal terminal, and I can either push it to GitLab or GitHub. And then after that sets, for instance, like maybe unit tests that I've already set up. And now that kicks, now the code that I've sent to GitHub, it automatically kicks all the unit and integration tests depending on the language that I have. So if I'm programming or pushing code in Golang, then it does the same for that specific language. After that, I deploy it to a testing environment. And after that, I do things like acceptance tests and things like those, and then I move to production. So that is a simple maybe workflow sort of that I use in my day-to-day enablement to help me to do this continuous automation. Sometimes when you're dealing with clients that have high feedback loops, it's very interesting how you want to handle those feedback loops within your CI/CD pipeline. So the first instance that I've talked about is pretty straightforward. But now when you're dealing with high feedback loops, the way Amos was talking, that you have high feedback coming from your customers and back to you, such that you're continuously updating your code and thinking about it, the design bit of it, the application bit of it, how it works. How do you do feedback loops in your CI/CD pipeline? So it takes a very interesting perspective how to do it. So you do things like continuous design, where maybe you have you're dealing maybe with an API that hits a specific money wallet, and then you're designing APIs around that such that users are very efficient in using that API. So you continuously design that API. And then the next bit of it also, maybe you can continuously analyze whatever code you're deploying, and then you also need to continuously collect data. So you can use metrics, the things like Amos was talking about, the metrics tools that you were talking about. So if you don't have enough resources, you can use things like Prometheus. Prometheus is open source. It was released by SoundCloud. So it can help you to do very, very good metrics. Or you can use things like open tracing to discover some of these things that you want to use. Or probably you want to use FluentD. and it's very, very good for monitoring and observability. So with respect to CI/CD, we have that continuous workflow, and then this feedback loop. Maybe Amos can add what's his experience with CI/CD.
I think I'm not going to add onto the definition. Maybe just the benefits of what you gain by adopting CI/CD. You don't have to continuously engage your quality team to do tests, so that they now spend less time doing the testing because you've automated the testing bits during the build. I mean, after every build, they can now focus on the quality culture. So in this case, you'll get less bugs that get shipped to production, and because they are captured early in the process, and you can now have less context switching because the developers will concentrate a lot more on what they are doing without having to worry about something break. If it breaks during the build, it's not in production, and that gives you more reliability. Another bit is you take that deployment complexity, because now it's repeatable and you're able to fix any part of that pipeline, and subsequent releases are accelerated by that feedback at every stage. Where you have a build, if the build breaks, the developer can fix it. If the testing breaks, you can be able to actually come back and understand whether it's a test case that you've put, or it's the software or the business logic that is not working. So I think the other bit is maybe very important for us to think about in the CI/CD is, do you want to go all the way to continuous deployment? And in that case, you need to build things like feature flags that will allow you to control what the customer can see or can be available to the customer or the user of the solution as you deploy continuously. Because in this case, then you'll have everything going to production as you develop, and then every single developer or support person just concentrate on their bit of work. So I think for me, those are some of the benefits, and that means CI/CD removes the risk of getting buggy software, and always having something that is repeatable and safe to do at every time.
Wonderful. Thanks for that. So on to our last kind of question. What are some of the DevOps best practices? I know we've been talking about the tools that you've been using. Maybe we could, you guys can mention in brief some of your favorite tools and why you use them. And we can start with William.
Okay, thank you very much, Max. I have talked about some of the tools that I use, but some of them maybe we use them as developers. For instance, things like your version control. It's very basic. Sometimes people don't see the importance of it, but having version control really helps you. That's the very first step in where you want to start automating some of these things that you're doing. So pushing that away from your machine into maybe an automated software version control, like maybe GitHub, GitLab, or others. And then how do you want to do like things like process management, and maybe how do you want to release your softwares? So I know we have not talked about things like Jenkins. So maybe you have decided that you want to use things like Jenkins and such to help you do like automated build management and testing and those sort of things. And also, if you're dealing with a lot of configuration automation, you can use Chef or Ansible. But for me, as a DevOps person, the sort of tools that I use in my day-to-day application is things like security, which at the heart of it is Vault. So I have like Vault instances running somewhere in a server. So that is meant to handle database credentials. So that is like automated, such that I don't have to have like a list of database credentials on my laptop, or somebody has like database credentials on a piece of paper, so that maybe you have a policy where you change them after every 3 months. So all this is automated such that you don't have to know the credentials that are there. So you can use Vault, which is highly secure, so long as you do the configurations properly and you make it highly available such that you distribute the load in various data centers, such that if one data center goes out because of outage, then the other two you're able to use. My other good tool that I use is Console. This is for things like load balancing. Sometimes I do it like I use it instead of Redis. It's a very good in-memory DB, especially when you want to push secrets on the fly automatically. Then one thing also I want to mention in passing about Vault is, for instance, sometimes you're dealing with highly sensitive information, and everything on transit is encrypted. Everything on rest is encrypted, such that there is no opportunity for anyone to pose as a man in the middle. So everything works with certificates and things like those TLS certificates or MTLS. So Vault is a very good way of enhancing security on day one. And then I talked about things like Istio. Well, now I've abstracted the application from my machine. I've abstracted my application from the infrastructure with Kubernetes. Now I have things like Istio. For instance, I have 2 or 3 rogue developers that have decided to pull down an application. I can use Istio to automatically take control of the whole infrastructure from them. So I can make changes without going through them. So I just do it from my machine if you have rogue developers. It's very helpful, especially when you're dealing with money, because you can have rogue people that decide to lock you out of some of these applications. So how do you want to abstract your application, your infrastructure, such that you can always log into these applications that you have when you have rogue software developers? So things like Istio, which has things like Sidecar, comes into place. And then the other bit that I like so much is Prometheus, that helps me to do my metrics, because you cannot afford to fly blind. If you fly blind, you will hit the wall and you'll crash. So you have to know where you're going. Metrics really help you. So basically, there is a whole list of tools that I use that I would gladly talk about, but I think because of time, I'll just hand it over to Amos.
Okay, you've done a very good job on that one. Maybe one of the other bits is to think about release management. For things like mobile application, you can use a tool like Fastlane to automate your releases. We talked about infrastructure as code, and there are tools like Terraform, or each of the providers, I think they have their version of it, like AWS, which I'm a bit conversant with, use CloudFormation. And then, of course, you need to think about application performance management that will be able to pick how the application is, and you're able to actually point out where the issues are happening. So in this case, you can go for either the commercial ones like New Relic, Dynatrace, Datadog, or you can also take NSignalFX, or you can look for open source one like SolarWinds or something like that. So for again, there's a bit of GitOps, and GitOps is where we are able to do tool-based deployments. You have tools like Clcd, Jenkins X, which will be able to help you that. And of course, you need to have a place where or a storage for your artifacts. So when you have, let's say, like registries, Docker registry, if you have jar files or Artifactory, Nexus, and all these tools need to work in one concerted way. So you have to do a bit of integration of each of the tools that you have. You have to think about that as you go along. And of course, feature flags. You have launched Darkly, and there are many others that you can actually utilize.
Yeah, I forgot to talk about Docker. How come? Let me just give something a little bit about Docker, especially when you're doing multi-stage builds. I think people with programming backgrounds in C++, C, or Java, that you have to compile, you have to do stuff. So maybe you're worried how maybe you're pushing applications and then you have to sync your dependencies, you have to build. And then after building the jar files that you have, maybe you want to know is the jar file is the thing that you want to use. So things like those, you can use Docker files. Docker files is like a template, like a YAML file that you can use to design how your application runs, basically how to package it and how to ship it and how to make sure that it runs in your local environment and production environment. So the concept of multi-stage builds, that you have to stage your builds in a certain fashion, especially for these languages that require builds before you use the final artifact. For Golang people like us, I think it's pretty interesting. You just have to build your application on your local machine. And then the final artifact is because it runs, it pulls all dependencies, and you can just deploy the final artifact on your production environment. It just runs. It doesn't have to pull dependencies from everywhere. And then people who are doing Node.js or JavaScript, you run into things like node modules and things like those, package dependency. How do you want to make sure that you're pulling the right dependency, that nobody is standing as a man in the middle somewhere with those dependencies? So things like multi-stage builds can also help you to deploy your node application such that you only deploy the final application to production. So it's very interesting, some of these tools that we have in the market. I think that is what I wanted to add.
Thanks, William. Thanks, Amos. That was awesome. We've come to the end. Thanks for sharing. I mean, we've gone through the journey of DevOps from from code to building a test bed to deploying it, and all of this with the eye to kind of, as you've said, reduce costs, but at the same time deliver a product faster to the market. So with that, I'll just choose a few questions. I'll choose about 3 questions. We have a platform called Slido that there have been some questions asked. And this can be open to anyone. The first question is, can a DevOps engineer and software engineer at the same time? Can I be a DevOps engineer and a software engineer at the same time, or do I need to specialize? This to anyone, William or Amos?
Yeah, I think it's a pretty interesting question. Like I said, DevOps is not a tool or a process. It's sort of like a culture. It's like a radical shift in the way your organization does things in terms of automation. So basically, you can be a software engineer and you do develop operations, things from development to ensure that things are working within your production environment smoothly. So basically, that culture shift where you deploy things from your laptop to production, that in itself is developer operations. So you can be things like a software developer, you can be a technology manager, you can be a software tester, you can be a product owner, you can be a DevOps architect, you can be an automation engineer, you can be an integration specialist, you can be a security engineer, you can be a software tester or at least release engineer. None of those hinders you from being a DevOps person. DevOps is just a name, it's a culture. So it depends with how your organization wants to call you. Otherwise, you'll be just doing develop operation stuff. So yes, it's a long way to answer the question. You can be both.
Okay, thank you. The next question is by DevCodes, and he asks, what should be the ideal DevOps implementation for an early stage startup? this one again is open to either William or Amos.
Okay, I think I'll take that one. When I look at early stage, you want to minimize minimize the expenses and actually optimize the infrastructure that you're running. So the optimum is to utilize open source and most likely go for cloud-based solutions. So most of these cloud providers have inbuilt cloud tools or pipelines that will be able to help you to adopt or do your work quickly, and most of them are free to use.
Okay, so setting up the infrastructure in a way that all costs are completely bare minimum, which obviously helps with the sustainability of the business while running or rather launching whatever product they have. All right, and the last question is by Debugger. What is the difference between continuous development and continuous delivery? What tool can one use in code analysis? So I think that's a two-part question, but for anyone can take that. I can ask it again. What is the difference between continuous deployment and continuous delivery?
Okay, I'll take that one. The first one part.
Okay.
Okay. When you look at continuous delivery, it's a process of coming up with a build or an artifact that is deployable to your production. The stage for deploying can be either manual or automated. So the delivery bit is that you're ready to deploy to production, and then that delivery can either be scheduled. That deployment can be scheduled, let's say, either weekly, daily, fortnightly, or monthly. So that is a delivery bit. Is you've built, you've tested, it's ready for deployment. On continuous deployment, the tool that finishes that bit of coming up with an artifact that can run on the environment. So in this case, you have a Docker image or a Docker container. We'll now go ahead and have something like a pull-based mechanism that automatically deploys that artifact to production. So in this case, it goes further than just getting an artifact and deploys it to the production environment. In this particular case, you need a mechanism of ensuring that because you're continuously deploying features and solutions to the customer, you need to have a way of actually controlling how the customers get access to these features. There are methods like A/B testing, canary releases, blue-green. Those are methods where you're able to come up with a completely with an environment that the customers can access and use when you're using continuous deployment. And you can also use feature flags to actually ensure that a feature is only available to the customer when you turn it on.
Yeah, maybe to add, Amos has talked about it. So continuous delivery, I know all programmers that I hear, they like if you will find a way that you want to automate stuff and not creating things like spaghetti code, code that is not readable by anyone. So I think for me, in my experience, just like Amos has said, continuous delivery enables you that all releases that you're doing is frequent, and it is very fast, and above all, it's boring. You make sure that it's boring such that the things that you're deploying are things that now are automated, and now things that maybe when you do them, the stages of how you do them. For instance, there are programmers who usually want to show off that they are able to do this and this and this and this and this. And then maybe it's for a single application. Maybe you're configuring management for a single application, and then you have to do that for a particular application. Now imagine you're doing that for an enterprise company, and then you have 1,000 applications, and you have to do configuration for each and every application. So it means you have to do that task 1,000 times. So that is a boring task that you are able to achieve. Now, continuous delivery helps you to automate all of that and make it the boring tasks to help you and abstract that pain away from you, such that everything is frequent, fast, and as I've said, boring. Now, some of this we have to really focus on. It's a cultural shift focus, the way we've really talked about. So your management really has to really think through how they want to do this sort of stuff. And with advancements like virtualization and containerization, this means that every developer from Golang, Java, Node.js, you have a pretty operational environment that you can use to make sure that you have continuous integration and delivery within your pipeline. So this consistency is very important for people who are doing development work and production environment. So basically, DevOps is an accelerator for that.
Thank you. Very last question, because I know we have 3 minutes left. Very last question. Do you organize CI/CD pipelines for a company with your set of standards, or do you enforce the set of standards by the organization in any given scenario?
I didn't get that. Come again.
Do you, one sec, I think there's a few more questions. Yes. Do you organize CI/CD pipelines for a company with your set of standards, or do you enforce the set of standards set by the organization in any given scenario? So do you have your standards, or do you follow an organization standards whenever you set up a CI/CD standard, a CI/CD pipeline, sorry?
Okay. What I look at DevOps is, I'll talk about my environment. We come up with templates that can be borrowed by any team that wants to adopt DevOps. And in this case, when you talk about DevOps, remember it's about owning. You build, you develop, build, deploy, and run. That's mainly the mantra behind it. We come up with templates and some guidelines and usage examples of those pipelines, and then every team can adapt it to what they have. A better way of looking at it is we don't enforce, we encourage continuous improvement by guiding what kind of automation that can happen within the organization. And especially when you have huge development teams, huge numbers of development teams, like in some of the enterprises.
Yeah, to add on what Amos has said, basically, as an organization, first of all, the sort of product that you're engaging in depends on a number of things. First of all, it depends on regulators. For instance, if you're moving money, then you're subject to certain regulators in the country. For instance, Central Bank of Kenya, the Capital Markets Authority. They have clear guidelines and policies on where some of the data resides. And when you come about to people like your stakeholders, there are a set of policies depending on the type of product that you're building. So basically, some of these policies and rules already in the market that already gives you ground rules where now you're able to determine the sort of CID pipeline that you use. For instance, if you're moving money, there are certain instances where you are required to have your own data center living within your premises. Some of the information is not supposed to live on cloud. So how you approach that, now your CI/CD pipeline will depend on the nature of the policies that you have in the company, and also the policies that are being enforced by regulators. So it's something that is adaptive, something that you can use based on the nature of business that you have, and you can really customize it to fit within your specific use case.
Thank you. Thank you for that. Our time is up. I think Alela's posted the link to the feedback form on the chat. once again, I want to thank our guests, William and Amos, for joining us today. Thank you guys for sharing your experiences and insights into DevOps. It's a wide landscape, and I hope this session has served to narrow it down for some of the devs in our different communities. It's really important, and I'm really happy that you guys have gotten the chance to share, because right now there's not a lot of engagement, and this is one of the ways DeCodEd and Google developers engage developers across Kenya and across Africa. And we're always looking forward to the next Thursday and the next Thursday. So I'm really happy that you've been able to make it to this session. Thanks again, and thanks to everyone who joined.
Max, maybe just one last bit. Sorry for interrupting. Maybe you can follow up with how do you call them, Twitter handles, in case anybody has questions, or maybe further interactions within the topic of DevOps, the specific how do you call them, implementations and things like those. I think we will be ready to help.
Perfect. We can follow up. I think Alela will be able to send emails with all of these details, or you can post them directly here on the chat. Yeah, I think Alela is posting them on the chat. So yeah, thank you again, and we're looking forward to meeting with you guys next Thursday again. Next week, the session will be about building tech teams, and we'll have Victor Chilule and Grace Njihia here with us. So thanks again, William, Amos, if you have any last words.
Being the first one, I'm very happy to have these sessions, and I'm looking forward to the subsequent ones. It was a very short notice for me, but I'm happy to participate and share with the rest of the developer community. And thanks to DeCodEd and Google for enabling this.
Thank you so much, Emma, for availing time to speak at today's session. William, parting shot?
Thank you, everyone, for joining us. Like we've said, we've talked about DevOps is something that is very interesting, so we can always continue with the conversation off of this. So thank you very much for coming, and thank you, Google and DeCodEd, for making this happen. Thank you so much.
Okay. Thank you so much to William and Amos for joining. It's good to have you on board. So next week, we're going to be having a session on building tech teams led by Victor Chelule and Grace Njihia, both with technical expertise on working with small teams and growing them to larger teams. We hope to have you on board. In case you want to have contacts with William and Amos, the Twitter handle is W_Ondege for William and A Njega for Amos. I've actually placed them on the chat section. See you on our next webinar. Bye, everyone.
Thank you. See you guys. Bye-bye.